Hey guys, today you're going to learn about quadratic equations. If you haven't checked out my previous video yet, please do so. It's in the link below because without it you might struggle a bit. Anyway, quadratic equations. The first thing you should know is how to FOIL. FOIL stands for first, outer, inner, oops, there's a mistake there, last. Look at this example here. X plus 8 times x minus 2. This is in factored form. Now, when we're using FOIL and the distributive property, again, first, so x times x, again, that's the first here, x squared. Then minus the outers, minus 2x, then inner, plus 8x. Then last, minus 8 times negative 2 is negative 16. So 8 x squared minus 2x plus 8 minus 16. And we can combine like terms here. So our final answer would be x squared plus 6x minus 16. Now this is important because it's a good way to check your solutions and help find the zeros of functions. When trinomials in the form x squared plus bx plus c, you have to find two integers that when added equal b and if multiplied equals c. It's better if I show you. So look at this example right here. X squared plus 6x plus 8, and you can see it's in the same format of x squared plus bx plus c. So, in order to factor this, I have to find two terms that when added equals 6, and when multiplied equal 8. So let me come up with factors for 8. Let's see, there's 1 and 8, right? Negative 1, negative 8. There's negative 2 and negative 4. There's 2 and 4. And yeah, that's pretty much it. So, what here adds up to 6 but multiplies to 8? Well, we know all of them multiplies, the product of these factors are 8. So, what adds up to 6? 8 plus 1 is 9. Negative 1 times negative 8 is negative 9. Negative 2 minus 4, sorry. Negative 1 minus 8 is negative 9. Negative 2 minus 4 is negative 6. But 2 plus 4 is 6. And so there we have our two terms. They multiply and they equal 8. And when they're added, they equal 6. So now, since they equal 6 when added, we're going to replace 6x with 2x and 4x. So we're going to rewrite this equation as x squared plus, instead of 6x, 2x plus 4x plus 8. So that this is the same thing as this. 2x plus 4x is 6, but it's broken down. Now, we're going to factor. Here and here, what do you notice? There's a common GCF that can be pulled out here, which is x. And if we take that out, we're left with x plus 2, right? Now, for 4x plus 8, we can pull out a 4. So we're going to add, and then we're going to put 4 here, and then we're going to put x plus 2. Now, notice how the values inside the parentheses are the same, right? So we're going to take that and make it 1, x plus 2. Now what happens to these right here, the x and the 4? Well, since these values are the same, these are going to be added together and multiplied by this value. So it's going to be x plus 4, oh, you can't see it, no. X plus 4 times x plus 2, and that is our factor form. And normally we equal it to 0, and we set both values equal to 0. Here is the factored form, x plus 4 times x plus 2. Let's try a few examples. Factor each trinomial. X squared plus 11x plus 24. Let's look at this. Let's make a table. What times what equals 24 but adds up to 11? Well, let's see. There's 24 and 1, 12 times 2. There's, well, the negatives 2. Then there's 8 times 3, and, oh wait, here. So 8 times 3, that's 24, right? And if we add them up, 8, 9, 10, 11. So 8 plus 3 is 11, but it also multiplies to 24. Therefore, those would be our values. Now, we repeat the same process. We rewrite the equation, x squared plus 8x plus 3x plus 24. Alright, so now, let's pull out the GCFs. Remember to group it like this. Oops. Remember to group it So if we pull out a GCF, x, it's going to be x plus 8 plus, we can pull out a 3 from here. 3 times x plus 8. Again, we find the same values in here, so we're going to rewrite it as x plus 8, and then we have our values here, and we're going to rewrite that as x plus 3. And there are your factored forms. Let's try this one. R squared minus 2r minus 24. Now this is a little bit tricky because it's a negative, but we'll try it and see how it goes. Make a table. What adds up to negative 2, but multiplies to negative 24? So, let's see. It's the same thing. 24, 1, except, sorry, negative 1. Let's see. 8, negative 3, 12, negative 2, there's 6, negative 4, and oh, there, right there, 6 minus 4, 6 plus negative 4 is negative 2, but also is our factors of negative 24. So let's rewrite this equation again, and don't forget the negative. R squared plus 6r minus 4r minus 24. Let's factor that out again. So pull out a GCF again, r plus 6 minus 4. Now, because we use the distributive property, because there's already a negative here, this is going to be a positive here. And 4 times 6 is 24. These are the same value. This is right here, so we're going to rewrite it as, r plus 6 times r minus 4. Now notice, if we FOIL these values, we're going to come up with the exact same expression as before. Let's try it. X times x, remember FOIL, x squared plus an outer 3x plus inner 8x plus 8 3s are 24. So 8 plus 3 is 11, so x squared plus 11x plus 24. There, right there. Same equation. Then, same thing here. R squared, r squared minus 4r plus 6r minus 24. Negative 4 plus 6 is 2, r squared. I just realized I made a mistake. I'm sorry, guys. So, it's going to be actually negative 6 and positive 4, because right here, it's a negative 2. So, forget about all of this. It's going to be the same thing but reversed. So, it was factored previously into r plus 6 and r minus 4. But instead, we're going to switch the values here. It's going to be r minus 6 and r plus 4. Why? Because negative 6 plus 4 is negative 2, not 6 and negative 4. My bad. Sorry. Alright, here's another complication. What if there was a coefficient in front of x squared? That would be written as ax squared plus bx plus c. Now, in this case, it's a little bit different. In this case, the product of a times c has to be added up to b. That doesn't make sense, my bad. In this case, a times c, okay, you know what? I'll give an example. Say this was 4x squared plus 4x minus 6, we'll say. Okay, so we have to multiply a times c first. I don't know why, but it is what it is. So 4 times negative 6 is negative 24. So what are factors of negative 24 that add up to 4? Well, let's see. 6, negative 4, 12, negative 2, 8, negative 3, and vice versa. I can't really think of any other else. Notice how it does not add up to 4x. Well, that means it's not factorable. Okay? Alright. But we'll take a few examples out. Stuff that really is factorable. Let's factor this question right here. It says 7x squared plus 29x plus 4. So now we're going to multiply a times c. 7 times 4 is 28. So what are factors of 28 that add up to 29x? Well, this one is pretty simple. 28 and 1, right? So now here's where things get a little bit tricky. We're going to rewrite this equation, and we're going to have to pull out a GCF using not just x squared, but 7x squared. So let's rewrite this. So now let's pull out something from here. I see an x and I see a 7. So we're going to pull out 7x, and then we're going to write x plus 4. And then we're going to write up here, since this is 1 and x plus 4, we're just going to pull out the 1 here, x plus 4. So our final answer, since these values are the same, and these, well, they're left over here, our final answer will be 7x plus 1 times x plus 4. And that would be our final factorized answer, because you can't pull out anything from here anymore. Alright, that's it for today.